Have you ever tried to change something on a web page, maybe added a CSS rule, just a simple tweak, and absolutely nothing happened?
Oh, yeah.
Or maybe even worse, something else completely changed, something totally unexpected.
Definitely. You end up staring at the screen, back at the code.
Exactly. Wondering what invisible force is messing with your layout.
It's a classic CSS moment.
Welcome to the deep dive. Today, we're tackling exactly that kind of web development frustration. We're going to try and demystify CSS.
That amazing language that makes the web look, well, good and interactive.
We're peeling back the layers on some of those core ideas that, let's be honest, often trip people up. The things that lead to those moments where you're just thinking, why isn't this working? Our mission today is pretty straightforward. We want to give you a shortcut, really, to understanding the fundamental rules, how CSS actually works.
How browsers figure it out?
Yeah, how elements get laid out and how you can genuinely take control of your designs. We've got some great source material you provided, and we're going to unpack the really key bits of knowledge from them.
Make it practical.
Translate those sometimes dense rules into insights you can actually use.
It's so easy to feel overwhelmed, isn't it? There are just so many properties, so many selectors in CSS. It can feel like you're just guessing sometimes.
Totally. Throwing styles at the wall and seeing what sticks.
Right. But what's really cool, and what we'll dig into, is that once you get a handle on just a few key foundational concepts, really understand the why behind them, honestly, everything else starts to make so much more sense.
It clicks into place.
Exactly. We'll connect those dots for you, show you not just what these things are, but why they genuinely matter for building sites that are solid, look great, and crucially work well for everyone, no matter the device.
Okay, let's dive into that first big idea, the one that often feels like this hidden game of, I don't know, rock, paper, scissors. Specificity.
Specificity, yes.
You've definitely written CSS rules, probably rules that seem to contradict each other. But do you really truly know why one rule beats another when they're both fighting over the same element?
It's the invisible hand, isn't it, behind so many of those frustrating moments.
It really is. So break it down for us. What is specificity, fundamentally?
Okay, so specificity. Think of it basically as a weight or maybe a score that gets attached to every single CSS declaration you write.
Like points in a game.
Kind of, yeah. It's like the browser is a judge in a styling competition. When you've got multiple rules trying to style the exact same thing on the same element, say, the color of a paragraph, the browser looks at these scores.
And the highest score wins.
The rule with the highest specificity score, that's the one that gets applied. It takes precedence over everything else. It's just how the browser sorts out those conflicts.
Okay, so how is the score calculated? You said it's like a weight.
Right. The easiest way to think about it is like a 4-column value. Imagine like scores in diving or gymnastics maybe, but it's heavily weighted towards the left column.
So a high number in the first column beats everything else.
Pretty much, yeah. A 1 in the first column beats any number in the columns to its right. Let's break down those tiers, starting with the absolute heavyweight champion.
Right.
Inline styles. These are styles you put directly in the HTML tag itself using the style attribute, like b_style color.blue.
Okay, right in the element.
Yep. They have the absolute highest specificity. They score a massive 1,000 nothing in your regular CSS files can easily beat an inline style. It's like a direct order to that specific element.
Gotcha. Very powerful. What's next?
Next down the ladder are IDs. Selectors that target an element by its id attribute, like #myheader or #login button.
Hashtag something.
Exactly. These score a solid 0-1000. They're really influential because, by convention, IDs are supposed to be unique on a page. So targeting by ID is very specific.
Makes sense. So #header background is pretty likely to make the header blue.
Very likely, yes. Unless you do something crazy like an inline style on the header itself.
Right. Okay, IDs are strong. What's the next level down?
Below IDs, we get a group. Classes, attributes, and pseudo-classes. So selectors like #mybutton, or attribute selectors like #submit, or pseudo-classes like .hover or .focus.
So dots, square brackets, colons.
Pretty much. Each one of those, each class, each attribute check, each pseudo-class contributes to the third column. They each score 0,0,0,0,0.
Ah, so they add up in that column.
They do. If you have a selector like .button.primary, that's 2 classes, so its specificity in this category would be 0,0,0,0.
Interesting. Okay, and the lowest level.
Finally, at the bottom rung in terms of power are elements and pseudo-elements. These are your basic tag selectors like P for paragraphs, div for divisions, H1 for headings, and also pseudo elements like before or after, which we'll get into later.
Like P font size, 16px.
Exactly. Each of those contributes to the fourth column, scoring just 0001 per instance.
Okay, so inline styles are king, then IDs, then class attributes, pseudoclasses, and finally basic element tags.
That's the hierarchy. And it's also really important to remember what has zero specificity.
Oh, right, things that don't add to the score.
Exactly. The universal selector, the star, adds nothing. Combinators, the space for descendant, the for child, the plus for adjacent sibling, the general sibling, they add zero specificity.
So div P isn't more specific than just P because of the at.
The tip itself adds nothing, but the div adds 0000 and the P adds 0001. So div P has a total specificity of 0002, which is higher than just P at 00001. The combinator just defines the relationship.
Ah, okay, that makes sense. What else has zero?
The .not pseudo class itself adds zero specificity. But, and this catches people out all the time, whatever selector you put inside the parentheses of .not does count towards the total specificity.
Tricky.
It can be. So let's make this concrete with an example, maybe from the source material. This really helps see the power differences. Imagine you've got this bit of HTML div-id my div class container, p class text. This is a paragraph.p div.
Okay, simple enough. A div with an ID and a class containing a paragraph with a class.
Right. Now let's throw three conflicting CSS rules at that single paragraph. Rule 1. Just an element selector.p color.blue. What's its score?
Fourth column, 1 point. 0001.
Perfect. Rule 2. A class selector.text color.green. Its score.
Third column, 1 point. 001 S here.
Again. Now, because 001010 has a 1 in the third column, where the first rule had a 0, this rule wins so far. The paragraph would be green.
Class beats element, got it.
Rule 3. An ID selector combined with an element selector. Hashtag myDP color.red. How does this one score?
Okay, hashtag my div is an ID, so that's 0100, and P is an element, 0001. So add them up, 0101.
Exactly. Now compare 0101 to the class selector's 010. The ID rule has a 1 in the second column, which is way more powerful than the 1 in the third column for the class.
So the ID rule wins. The paragraph ends up red.
Precisely. Even though the class selector.text looks like it's directly on the paragraph, the rule involving the parent's ID, hashtag mydivp, is ultimately more specific according to these calculations.
That's a fantastic walkthrough. It really clears up how a small change in the selector, like adding an ID, can totally flip which style wins. I've definitely wasted time wondering why my lovely blue wasn't applying.
Oh, me too.
Many times.
Only to find some other rule, maybe way up in the style sheet, was just more specific. But hang on, what if two rules had the exact same specificity? Like if I had two different class rules targeting the same element, both scoring 0010, who wins then?
Excellent question. That brings us to the second tiebreaker in what we call the CSS cascade. If the specificity scores are identical,
Then what?
Then it comes down to source order. It's simple. The rule that appears later in your CSS code wins.
Later in the file.
Later in the file, or if you have multiple style sheets linked, the rule in the style sheet linked later takes precedence. Or even styles in a style block in the HTML head versus an external file. It's just last rule declared wins. Okay, so the order matters if the scores are tied. That's good to know. Now, here's where it gets really interesting. Because isn't there a way to just cheat? To ignore all this careful specificity calculation?
Hey, cheat is one way to put it.
I'm talking about that important thing, the sort of override button.
Right. Important. It is indeed a powerful tool. You could call it the nuclear option in your CSS toolkit.
Nuclear option. Sounds dramatic.
Well, it basically overrides all other specificity calculations. It doesn't matter if another rule has an inline style and ID, 10 classes. If a declaration has .important tacked onto the end, like color.red.important, that rule wins. Period.
Wow. So it just blows past everything else.
It does. The sources even mention that .important in your main style sheet, the author styles, will override styles in the user's custom style sheet, which normally has very high precedence for accessibility reasons.
So if it's that powerful, why not just sprinkle .important everywhere and make sure my styles always win? Seems like it would solve a lot of headaches.
That's a really common thought, especially when you're first learning or fighting a stubborn style. But it leads directly to the big warning sign that comes with .important.
There's a catch.
A huge catch. While it's tempting as a quick fix, using .important excessively or just casually is generally considered really bad practice. It can turn your CSS into an absolute nightmare to maintain.
How so?
It creates an inflexible cascade. It basically breaks the predictable specificity system we just talked about. Imagine you put background-color blue.important on a button early in a project.
Okay.
6 months later, you, or maybe another developer, needs that button to be green for a special promotion. They add a new, more specific class, .promo button, background color,
Grimes got important is still winning.
Exactly. The only way to override that important is with another .important on the new rule. So now you have background.color.green.important. This leads to what people call specificity wars, or important hell.
Fighting .important with more .important sounds messy.
It's incredibly messy. Your CSS becomes brittle, unpredictable, hard to debug, and just painful to work with. It's really meant as a last resort. Maybe for overriding styles from a third-party library you can't modify, or for a very specific utility class, but definitely not for everyday styling. It undermines the whole point of the cascade.
Okay, lesson learned. Use .important with extreme caution, if at all. So understanding specificity and .important is crucial for debugging, for writing CSS that behaves predictably. But knowing why styles apply is only half the puzzle, right?
Right.
The other half is understanding how much space those style elements actually take up. Because if you've ever set a width to, say, 300 pixels and then watched your element somehow become 350 pixels wide.
Oh, yes. The mysterious growth.
It's a whole different kind of frustration. Which brings us neatly to the CSS box model, the invisible layers around every single element.
The box model. Absolutely fundamental. If you don't get this, layout will always feel like a battle.
So every single HTML element, a paragraph, an image, a button, a whole section, the browser treats it like a rectangular box, right?
Exactly. But it's not just one simple box. It's more like layers. Concentric boxes, one inside the other. Like an onion, or maybe those Russian nesting dolls.
Okay, I like the onion analogy. Peel it back for us. What's at the core?
At the very center, you have the content. This is your actual stuff. The text you type, the image file, the video player, maybe other HTML elements nested inside.
The visible part.
Usually, yes. Its dimensions are primarily set by the width and height CSS properties. So if you say width 300px, that's the space for your text or image.
Got it. Content first. What's the next layer out?
Surrounding the content is the padding. Think of this as breathing room inside the box, between the content and the edge, or the border.
So it pushes the content away from the border.
Precisely. It stops your text looking squished right up against the sides. You control it with properties like padding top, padding right, padding bottom, padding left. Or you can use the padding shorthand.
Like padding, 20px, for all sides.
Yep, or padding. 10p by 20px for 10px top, bottom, and 20px left, right. Very flexible.
Okay, content, then padding. What's next?
Outside the padding, you have the border. This is the visible line you often see around elements.
The actual box outline.
Exactly. It acts as the visual boundary. You can style it with border width, border style like solid, dashed, dotted, groove, ridge, lots of options, and border color.
And there's a shorthand for that too, right? Border. Yep. 1px, solid black.
Correct. And you can also use border radius to give your boxes nice rounded corners, making them look a bit softer, more modern.
Cool. So content, padding, border. Is that it?
One more layer. The outermost layer is the margin. This is the space outside the border.
Ah, so this is the space between different boxes.
Exactly. Margin creates separation between an element and its neighbors. It's like the element's personal space. And just like padding, you've got margin top, margin right, margin bottom, margin left, and the margin shorthand.
Content, padding, border, margin. CPBM.
Okay, now. This leads to that frustrating width problem I mentioned. Why does my box sometimes get bigger than the width I set? Ah, yes. This brings us to the box sizing property, and understanding this is, as you said, a total aha moment for so many people learning CSS.
Okay, hit me with the aha.
By default, browsers use box sizing, content box. What this means is when you set width 200px, that 200px applies only to the content area.
Just the innermost layer.
Just the content. Now, if you also add, say, 20 pixels of padding on the left and right, and a 5-pixel border on the left and right, the total width the element actually takes up on the screen becomes 200px content plus 40px padding plus 10px border, 250px.
What? So the width I set isn't the real width. That's bonkers. No wonder things overflow.
It feels completely unintuitive, right?
Yeah.
This is the source of countless layout headaches. But there's a fix.
Please tell me there's a fix.
There is. You can change the behavior by setting box sizing, border box.
Border box. Okay, what does that do?
When you use border box, The width and height you specify include the content, the padding, and the border.
Wait, really? So if I set width 200px and box sizing border box, and then add padding and border?
The element will still be exactly 200 pixels wide overall. The browser automatically shrinks the content area inside to make room for the padding and border, all within that total width you define.
That makes so much more sense. The size I set is the size I get.
Exactly. It dramatically simplifies layout. You set a width, and that's the space it occupies. It's why many developers now apply box sizing, border box, to basically everything on the page right at the start of their CSS.
Right.
It makes layouts predictable.
Game changer. Okay, border box is my new best friend.
Now, there's another weird quirk you hear about, especially with vertical spacing. Margin collapsing. It sounds like margins just disappear sometimes.
That's a pretty good description. Margin collapsing is another one of those CSS behaviors that can seem mysterious until you understand the rules. And crucially, it typically only happens with vertical margins, top and bottom, not horizontal ones.
Only top and bottom margins.
Okay.
And usually between elements that are next to each other. Primarily between adjacent block-level elements in the normal flow of the document. Things like paragraphs, headings, divs. It's actually designed to prevent excessive white space, like between paragraphs of text, making things more readable by default.
So it's a feature, not a bug.
Technically, yes. But it can behave unexpectedly if you're not aware of it. There are a few main scenarios where it happens.
Lay them on me.
First, adjacent siblings. This is the most common one. If you have two paragraphs, one right after the other, and the first has margin bottom, 20px, and the second has margin top, 30px.
You'd expect 50px of space between them, right? 20 plus 30.
You'd think so. But with margin collapsing, they don't add up. Instead, the larger of the two margins wins. So the space between them will just be 30px. The smaller 20px margin effectively gets ignored or collapses into the larger one.
Wow, okay, so the bigger margin wins. What else?
Second, parent and first last child. This one's sneakier. If a parent element has, say, margin top, 50px, and its very first child element also has margin top, 30px, and there's no border or padding or inline content between the parent's top edge and the child's top edge.
And what?
Their top margins can collapse together. Again, the larger margin, 50px in this case, wins. And it can look like the parent element itself has been pushed down by 50px, even if the space was intended for the child. The same can happen between a parent's bottom margin and its last child's bottom margin.
Yikes. That sounds hard to debug.
It can be. You might add margin to a child and see the parent move. And the third scenario is an empty block. If you have a block element with no content, no height, no padding, no border, just margins, its own top and bottom margins can collapse together, effectively making it take up zero vertical space, even if you declared margins on it.
Huh. So how do you stop margins from collapsing if you don't want them to, if you need that combined space?
Good question. There are several ways. Adding even just 1px of padding or transparent border to the parent element often works, as it creates a separation.
Ah, breaks the connection.
Exactly. Also, taking elements out of the normal block flow often prevents it. If the parent or child is using display, flex, display.grid, or display inline block, margin collapsing typically doesn't happen between them or their children in that context.
So modern layouts help avoid it.
They often do, yes. Another common trick is setting overflow, auto or overflow, hidden on the parent container. That also tends to contain the margins.
Okay, useful tricks to have up your sleeve. Now, shifting from spacing between elements to positioning them, a super common task is centering something horizontally. What's the go-to margin trick for that?
Ah, the classic centering technique is beautifully simple. For a block level element, if you give it a specific width that's less than its container.
Like width, 80%, or width, 600tx.
Exactly. Then you just set its left and right margins to auto. So margin left out auto, margin right out auto. Or the shorthand margin, 0 auto, if you don't need top bottom margin.
Margin, 0 auto. I've seen that everywhere.
And what auto does here is tell the browser, take whatever horizontal space is left over in the container and distribute it equally between the left and right margins.
Pushing the element into the middle.
Perfectly centered. Works like a charm for main content areas, containers, cards, anything block level with a defined width.
Awesome. Okay, let's try and tie all this box model stuff. Padding, border, margin, box sizing, centering together. Imagine we're building, say, a product card for an online shop. How would these concepts work together?
Great example. A product card is perfect. Let's say we have a div with a class, the product dash card.
Okay.
Inside, we have an image, a title, a price, maybe a description. First, to stop that content bumping right against the edges of the card, we'd use padding.
Give it some internal breathing room.
Exactly. Maybe padding. 1M or padding. 15p by 20px. So the text and image look nicely spaced inside the card's boundary.
Makes sense.
Yeah.
Then the card itself needs to look like a card.
Right, so we'd add a border, maybe border, 1px solid #gray line, and perhaps border radius. 5px for slightly rounded corners, make it look a bit softer.
Okay, padding inside, border around it. How do we space multiple cards apart if they're in a list or grid?
That's where margin comes in.
Right.
We'd apply margin to the dot product card itself, like margin.
Yeah.
This pushes each card away from its neighboring cards, creating a nice gutter or space between them.
Padding inside, margin outside. Got it.
And the crucial final touch.
Let me guess. Box sizing. Border box.
Absolutely. We'd set box sizing, dot border box, on the dot product card. Why? So that if we decide each card should be, say, width 300px, that 300px includes the padding and the border we added.
So it doesn't accidentally become 332px wide because of 15px padding and 1px border on each side?
Exactly. Our card stays precisely 300px wide, making our grid layouts predictable and preventing weird wrapping or overflow issues. The padding and border are carved out from the inside of that 300px width. It just makes everything work as you'd expect.
Brilliant. That really shows how they all work together. So we know how elements take up space. But deciding how much space the actual numbers we use for width, height, padding, font size, that involves CSS units, right? And it's not just pixels anymore.
Not at all. Pixels are just the beginning. Choosing the right unit is fundamental to making designs that are not just sized correctly, but are also flexible and responsive. This is key for modern web design.
So when we're defining sizes in CSS, we need these units to give the numbers meaning. Like 20 doesn't mean anything without px or im or something after it.
Exactly. And the units we choose drastically affect how the browser interprets that number. We generally split them into two main camps,
Right.
absolute units and relative units. Understanding the difference is crucial for building adaptable layouts.
Okay, let's start with the familiar ones, absolute units.
Right. Absolute units are fixed. Their size doesn't change based on the parent element, the screen size, or user settings like default font size. They represent a specific unchanging measurement.
Pixels, px are the main one here, right?
Pixels are definitely the most common absolute unit. We tend to think of a pixel as one dot on the screen. While the physical size of that dot can vary a lot between different screens, think a standard monitor versus a high-res phone screen within CSS, a px value is treated as a fixed reference point.
So 10px is always 10px on that specific device.
Pretty much. Pixels are great for things where you need precise, unchanging size, like border, 1px solid black. You want a crisp 1-pixel line. Or maybe for tiny icons or elements where scaling isn't desired.
But what are the downsides of pixels?
The main limitation is their rigidity. If you size everything, especially text, using only pixels, your layout won't adapt well. Text set in px doesn't scale if the user increases their browser's default font size for accessibility reasons. It can lead to inflexible designs that break on different screen sizes or for users with specific needs.
Are there other absolute units besides pixels?
Yes, though they're less common for screen design. You have ppace like in print, PC, piekas in inches, centimeters, millimeters. These represent physical measurements.
Big on a ruler.
Exactly. They're more relevant for print style sheets, where you know the physical output medium. For designing websites meant for screens of all shapes and sizes. Not so useful. They don't adapt well.
Okay, so absolute units are fixed, predictable, but rigid. That brings us to the other camp. Relative units. These are the ones that make things flexible, right?
Precisely. Relative units are the heroes of responsive design. Their value is calculated relative to some other value, which makes them inherently adaptable.
Let's start with one I see a lot but still find a bit confusing. M.
Ems. Okay, an M unit is relative to the font size of the element itself. If the element doesn't have an explicit font size set, it inherits from its parent. If no parent has one set, it goes all the way up to the browser's default, which is usually 16 pixels.
So font size, 2M, means twice the current font size.
Exactly. If the parent element has a font size of 16px, then 2mm on a child element makes its font size 32px. But here's the tricky part. If that child element is then nested inside another element that has, say, font size 1.5mm, which would be 24px based on the 16px grandparent.
Oh, wait. So the 2M inside that would be 2 times 24px. So 48px.
Exactly. This is the compounding effect of elements. Because each M is relative to its immediate parent's computed font size, it can get complicated quickly in deeply nested structures. You can end up with unexpectedly huge or tiny text if you're not careful.
Yeah, that sounds like a recipe for confusion. Is there a simpler way?
There is, and it's generally the preferred way now. REM, which stands for Rootem.
Rootem. How's that different?
Where units are always relative to the font size of the root HTML element, nothing else. It ignores the font size of any parent elements.
Always the top-level HTML tag.
Always. So if the HTML element's font size is the default 16px, then font size. 2M anywhere in your CSS will always mean 32px. Doesn't matter how deeply nested that element is.
Ah, that's much more predictable. No compounding craziness.
Exactly. It makes scaling typography and spacing across your entire site much easier and more consistent. You can set a base font size on the HTML element, maybe adjust it slightly with media queries for different screen sizes, and then all your rem units throughout the site will scale proportionally. It's fantastic for accessibility and responsive design.
Okay, rem sounds like the way to go for most things, especially fonts and spacing. What about units related to the screen itself?
Good question. Those are the viewport units. VW viewport width, VH viewport height, VMin viewport minimum, and VMax viewport maximum.
Viewport. That's the visible browser window area, right?
Correct. 1 VW is equal to 1% of the viewport's width. 1 VA is 1% of the viewport's height.
So width. 100 VW would be the full width of the browser window.
Precisely. And height. 100 VH would be the full height. These are brilliant for creating full-screen hero sections or elements that need to scale directly with the browser window size.
What about VMin and VMax?
VMin is 1% of the smaller dimension, either the width or the height. So you have a portrait phone screen. 1 VMin would be 1% the width. VMax is 1% of the larger dimension. They're useful for ensuring elements scale proportionally, but perhaps stay within certain bounds relative to the overall viewport shape.
Any catches with viewport units?
Minor ones. Sometimes mobile browser UI elements, like address bars that appear or disappear or scroll bars, can slightly change the effective viewport size, which might cause small jumps if you're relying solely on VH units for critical height calculations. But generally, they're very powerful.
Okay. What about percentages? They seem relative, too.
They are. Percentages are relative to the size of the parent element, so width. 50% means an element will take up half the width of its direct container.
That seems straightforward.
It usually is for width. Where percentages can get tricky is with properties like height or padding and margin. For height, 50% to work, the parent element usually needs to have an explicitly defined height itself. And vertical padding margin percentages are often calculated based on the width of the parent, not the height, which can be surprising.
Wait, vertical padding percentage based on parent width?
Often, yes. It's
Yeah.
one of those CSS quirks. So while percentages are great for fluid layouts within containers, you need to be sure you know which parent property they're relative to.
Good to know. Are there any other relative units worth mentioning?
There are x and change, which are related to font metrics. X is roughly the height of a lowercase x in the current font, and ch is the width of the 00 character. They're sometimes used for fine-tuning things related to text layout, like setting a max width based on a comfortable number of characters per line, but they're less common for general component sizing than M, rem, or viewport units. So knowing how to size elements using these different units is crucial. And that leads us perfectly into our next topic. How do we select the right elements to apply these sizes and styles to with real precision, beyond just simple classes and IDs?
Right. We've covered basic selectors and specificity, but CSS offers way more powerful tools for targeting, doesn't it? It feels like moving from a blunt instrument to a laser scalpel.
That's a great analogy. Advanced selectors let you target elements based on their attributes, their current state, their position in the HTML structure, or even let you add content purely through CSS. It's about making your style sheets smarter and more concise.
Okay, let's start with attribute selectors. You mentioned these briefly when talking specificity. How do they work for targeting?
Attribute selectors are super useful because they let you style elements based on their HTML attributes and the values those attributes have. It links your styling directly to semantics or data.
So beyond just class and need.
Way beyond. The simplest is just checking for the presence of an attribute, like data tooltip, that selects any element that has a data tooltip attribute, no matter what its value is. Useful for applying default styles to anything that has a tooltip.
Like adding a little help cursor?
Exactly, like data tooltip cursor.help. Then you can get more specific with values. Input type text targets only input elements where the type attribute is exactly text. Great for styling different form inputs uniquely.
Okay, that's handy. What about partial matches?
Yeah, CSS has several ways to do that. At vValue checks if the attribute value starts with the specified value, like evref HTTPS to style all secure external links. Add a value checks if it ends with the value, like mgsrc.png to target only PNG images. Add value checks if it contains the value anywhere within it, like MDSRC thumbnail, to find images with thumbnail in their file name. @read value checks if it contains a specific whole word and a space-separated list. Useful for classes like class warning would match class message warning important, but not class warning message.
Wow. Okay, that's quite a lot of control just based on attributes.
And you can make them case insensitive too. By adding an I before the closing bracket, like input type submit I, it will match submit, 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 etc. Makes your selectors more robust.
Nice. And you can chain them together.
Absolutely.
Yeah.
Add target, blank HES HTTP, would select only links that open in a new tab and point to an insecure HTTP address. Very precise targeting.
Cool. Okay, attribute selectors are powerful. What about styling things based on, well, things that aren't attributes, like when you hover over something?
Now you're talking about pseudo classes. These are keywords added to selectors, usually with a single colon, that let you style elements based on their state or their position in the document structure information that isn't directly in the HTML attributes.
State, like .hover.
Exactly. .hover is probably the most common. It applies styles only when the user's mouse pointer is over the element. Then there's .active for when an element is being activated, like a button being pressed down. And focus for when an element receives keyboard focus. Super important for accessibility, especially for form inputs and links.
And for links, there's .link and .visited, right?
Correct. .link styles, unvisited links, and definited styles links the user has already clicked on. Helps users navigate.
So those are based on user interaction. What about position?
Right, structural pseudoclasses are all about where an element sits relative to its siblings or parent. First child selects an element only if it's the first child of its parent. Last child selects it only if it's the last child. Dash child is incredibly versatile. You can use it to select elements based on their position, like --child odd or .nth child even for striping table rows, or .nth child for the third child, or even formulas like nth child 2n plus 1, which also selects odd children. Only child selects an element only if it has no siblings within its parent. Empty select elements that have no children at all, not even text. It really is. And then there are pseudoclasses specifically for form states, checked for styling, check boxes or radio buttons, enabled, disabled for styling interactive elements based on their state, and the validation pseudoclasses, .valid, .invalid, .required, .optional. These let you give users instant visual feedback as they fill out forms based on HTML5 validation rules.
Like highlighting a required field if it's empty.
Precisely. Super helpful for usability. And don't forget .that.
Yes, the negation pseudoclass. Selects things that don't match.
Yeah. Exactly. Button.not primary, styles. All buttons except those with the primary class. We already mentioned the specificity quirk. Itself is zero specificity, but the selector inside it contributes.
Right. P.highlight is more specific than just ppm.
Got it. Okay, this next one feels like actual CSS magic. Pseudo elements. Styling parts of an element that aren't really there in the HTML, like before and after.
It does feel like magic. Pseudo elements, usually denoted with double colons. Now, though single colons often work for backward compatibility with before and after, create virtual elements in the document.
Virtual, so they aren't really in the DOM.
Correct. They don't appear in the HTML source. Before creates a pseudo element that behaves like the first child of the selected element, and after creates one that behaves like the last child.
Okay, but what goes in them?
That's controlled by the content property, which is absolutely mandatory. If you don't specify content, the pseudo element simply won't render.
What kind of content can you put in there? Lots of things. Plain text strings, like content. To add a check mark before list items. You can embed images using content.url_icon.png. You can use CSS counters for automatic numbering, like content.counterchapter title. Or you could even pull text from an HTML attribute using add, like content.data tooltip to display a tooltip's text.
Wow, add sounds really useful. So you style these pseudo elements just like regular elements?
Pretty much. By default, they're inline elements.
Yeah.
But you can change their display to block or inline block, apply padding, margins, backgrounds, colors, positioning, almost anything.
What are some common uses?
People use them for decorative elements like custom bullet points, adding quotation marks automatically around block quotes, content.open quote, and content close quote, creating dividing lines, icons next to links. Lots of creative uses that keep your HTML clean.
That's very cool. But is there a catch? Maybe with accessibility.
Yes, that's the crucial accessibility note. Content inserted using before and after is generally not exposed to the accessibility tree.
Meaning screen readers won't read it out?
Usually, no. So you should only use pseudo elements for purely decorative content, or perhaps to visually duplicate information that's already accessible elsewhere in the real HTML. Never rely on .before or .after to convey essential information or functionality.
Okay, really important point. Use for decoration, not critical content.
Got it. So we have attribute selectors, pseudo-classes, pseudo-elements. What about relating selectors to each other, like select a paragraph only if it's inside a div?
Now we're talking about combinators. These are the special characters that sit between simple selectors and define the relationship between them.
The space, the greater than sign, those things. Exactly. There are four main ones. The descendant combinator, a single space, like div p. This selects any p element that is a descendant of a div, direct child, grandchild, great-grandchild, doesn't matter how deep. It's the broadest and potentially slowest combinator.
Yeah.
The child combinator, like div p, this is more specific. It selects only p elements that are direct children of a div, not grandchildren. Faster and more precise. The adjacent sibling combinator, plus, like h1 plus p. This selects the p element that comes immediately after an h1 element if they share the same parent, i.e. they are siblings. Only the very next one, the general sibling combinator, like h1p. This selects all p elements that are siblings of an h1 and come after it in the HTML source, broader than plus dib.
Okay, space for any descendant for direct child, plus for the very next sibling, for any following sibling. That gives a lot of structural targeting power.
It really does. And finally, there are a couple of modern pseudo-classes that help group selectors together.
Yes.
Where
Or you mentioned these are like superpowered grouping tools, make things tidier.
Exactly. They let you apply the same styles to multiple different selectors without repeating the entire rule block, making your CSS much more DRY. Don't repeat yourself.
How do it work?
You put a comma-separated list of selectors inside the parentheses. For instance, instead of writing separate rules for styling text inputs, email inputs, and text areas inside a form. Form input type email, input type email, and for type email.
You can just do
foreign
correct text.
Input email text area.
It's much
I mean,
cleaner.
that is much nicer.
So as dbearer and wearers do the same thing.
They achieve the same grouping effect, but there's one critical difference. Specificity.
Specificity again. It's everywhere.
It really is. It takes on the specificity of its most specific argument. So if you have Eastberg Barris, my class, hashtag #meArda, the whole selector will have the specificity of hashtag #myArd, which is high 0100.
So eSuarez can potentially make your selector much more specific than you might expect.
It can, yes. You need to be mindful of that. Where, on the other hand, always has zero specificity.
Zero. Always. Always. The selectors inside it contribute nothing to the overall specificity calculation. This makes where absolutely perfect for defining base styles, default themes, or resets that you want to be very easily overridden later on without needing high specificity or that important to do it.
So use where for defaults you want people to customize easily,
Yep.
and when you need the grouping but are okay with the higher specificity.
That's the general idea, yes. Where is fantastic for framework authors or for setting up foundational styles. So knowing how to target elements with this level of precision is incredibly powerful. But modern web design isn't just about styling individual bits. It's about arranging complex interfaces. And for that, we need the big guns of layout.
Flexbox and CSS Grid, the layout maestros, as you called them.
Yeah.
For years, layout felt like hacks, didn't it? Floats, clear fixes, table layouts.
Oh, the dark ages, yes. Floats were never really designed for full-page layout. They were for floating images and text. Using them for grids was always fragile.
But then Flexbox and Grid arrived and just changed everything, made layout make sense.
They're genuinely transformative. They provide robust, predictable, and flexible ways to arrange elements. Think of them as two distinct, powerful tools, each excelling at different kinds of layout tasks.
Okay, let's start with Flexbox. You called it the one-dimensional powerhouse. What does that mean?
It means Flexbox is primarily designed for laying out items in a single dimension, either as a row or as a column. It's fantastic for distributing space along that single axis and aligning items perpendicular to it. Perfect for navigation bars, form controls, card components, things that flow in one direction.
How do you turn it on?
Super simple.
Yeah.
You just apply display.flex to the parent container. That element becomes a flex container, and its direct children automatically become flexed items.
And then you control how those items behave.
Exactly. The main properties you'll use on the container are for alignment. Justify content controls alignment along the main axis, the direction of flow, row, or column.
Like centering things horizontally in a row.
Yep, justify content.center does that. Other options include flex start, default, items clump at the start, flex end, clump at the end, space between, first last items touch edges, space distributed between others, space around, equal space around each item, meaning half space at ends, and space evenly, equal space everywhere, between items and it ends.
Lots of options for spacing things out. What about the other direction?
That's the cross-axis, and you control alignment there with align items. Options include flex start, flex end, center, vertical centering in a row, for instance, stretch, default, items stretch to fill the container height width, and baseline aligns items based on their text baseline.
So justify content for the main direction, align items for the perpendicular direction.
Precisely. And if you want one specific item to align differently from the others, you can use align self directly on that flex item to override the container's align items.
Okay, that's container stuff. What about the items themselves? Can you control how they size?
Yes, that's where the flex properties on the items come in. There are three main ones: flex basis, flex grow, and flex shrink.
Basis, grow, shrink. What do they do?
Flex basis is like the item's ideal or starting size before any growing or shrinking happens. It works like width in a row or height in a column. It can be a length, like 150px or auto, based on the item's content. Flex grow is a number that determines how much an item will grow if there's extra space in the container. If all items have flex grow, 1, they all share the extra space equally. If one has flex grow, 2, and others have 1, it'll take twice as much of the extra space. Flex shrink is the opposite. It determines how much an item will shrink if there's not enough space. A higher flex shrink value means it will shrink more readily than others.
Okay, so flex basis is the starting point. Flex grow handles extra space. Flex shrink handles not enough space.
You got it. And these are usually combined into the flex shorthand property, like flex. 1-1 auto means grow at rate 1, shrink at rate 1, start at auto size. Or just flex. 1, which is shorthand for flex. 0%, meaning grow, shrink, but start with 0 size. So growth is purely based on available space.
Flex 1 seems really common for making something fill the available space.
It is. It's super useful.
Let's make this practical. A really common layout headache. The sticky footer. You know, the footer that needs to stay at the bottom of the browser window even if the page content is really short but should get pushed down naturally if the content is long? How does Flexbox solve this elegantly?
Ah, the classic sticky footer. Flexbox makes this so much easier than the old hacks. Here's the pattern. First, you treat the body element, or maybe a main wrapper div, as your flex container.
Okay, body display.flex.
And you want the main content and footer to stack vertically, right? So you add flexdirection.column.
Body display, flexdirection.column.
Got it. Now you need the body to always be at least as tall as the viewport. So you add min height, 100
Dot display, flex direction,
Yeah.
column, 100. Okay, makes sense.
Yeah.
Body fills the screen vertically.
Now imagine your direct children inside the body are header, main, and footer. The magic happens on the main element. You give it flex.
1, main flex. 1.
And that means, remember flex. 1 is shorthand for flex grow. 1, flex shrink. 1, flex basis. 0%. The key part here is flex grow. 1, it tells the main content area. If there's any extra vertical space left in the body, because the header, main content, and footer don't fill the 100 vase, you take all of it.
Ah, so the main area stretches to fill the gap, pushing the footer down to the bottom.
Exactly. If the content is short, main grows. If the content is long, main naturally takes up that space, and flex grow doesn't need to do anything extra. The footer just sits below it. It solves the problem beautifully with just a few lines of CSS.
That is elegant, much better than negative margins and wrapper divs. Okay, so Flexbox nails one-dimensional layout, but what about arranging things in rows and columns at the same time, like a proper grid?
That's where CSS Grid shines. If Flexbox is for lines, Grid is for, well, grids. It's a two-dimensional powerhouse. It lets you define complex layouts with explicit control over both the horizontal and vertical axes simultaneously.
So magazine layouts, dashboards, complex forms.
Perfect use cases for Grid. You start similarly, apply display.grid to the parent container.
Display.grid. Okay. How do you define the actual grid structure, the rows and columns?
Use the grid template columns and grid template rows properties on the container. Here you define the size and number of your grid tracks, the columns and rows.
What units can you use? Pixels, percentages?
All the usual ones, px, percent, m, rem, vw, vhr. But grid introduces its own amazing unit.
A fractional unit?
Yep. It represents a fraction of the available space in the grid container. This makes creating flexible, proportional columns super easy. For example, grid template columns, 1fr, 2r, 1fr, creates 3 columns. The middle one will be twice as wide as the outer two, and they will all resize proportionally to fill the containers with.
That sounds incredibly useful. No complex percentage calculations needed.
Exactly. You can also use auto, which sizes the track based on its content, and min content or max content to size based on the smallest or largest possible size of the content without breaking words or overflowing.
And there's a repeat function too.
Yes. To simplify things, instead of writing 1FR, 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 you can just write repeat for 1FR. Very handy.
Now, I've heard about autofit and autofill with min-max for making responsive grids without media queries. That sounds like magic.
It is pretty magical. This
Yeah.
is one of Grid's superpowers for responsiveness. You use it within repeat. For example, grid template columns, repeat, autofit, min-max 200px 1FR.
Okay, break that down. Repeat,
Our-
autofit.
Means we want multiple columns. Autofit tells the browser, create as many columns as can fit in the available container width based on the size defined next.
And the size is min-max 200px 1FR.
Right. Min-max defines a size range. It means each column must be at least 200 pixels wide. But if there's extra space after fitting in as many 200px columns as possible, distribute that extra space proportionally among the columns, max of 1FR.
So on a wide screen, you might get 5 250px columns. On a smaller screen, maybe 3 220px columns. And on a very small screen, maybe just one column taking up the full 1FR width.
Exactly. The grid automatically adjusts the number of columns and their widths based on the available space and the minimum size you specified. Autofill is similar, but with a subtle difference. If there aren't enough grid items to fill all the potential columns autofill creates, it will leave empty tracks. Autofit collapses those empty tracks, making the existing items stretch to fill the space. Usually, autofit is what you want for a gallery-like layout where items should fill the row.
That repeat autofit min-max pattern seems incredibly powerful for responsive design. Okay, so you've defined the grid. How do you put things into it?
Two main ways: line-based placement or named areas. For line-based, you tell an item which grid lines to start and end on. Grid lines are numbered starting from 1, so grid column, 1, 3, means start at column line 1, end at column line 3. This makes the item span the first two columns. You can use grid row similarly.
A bit like coordinates.
Kind of. The other way, which is often much more readable for complex layouts, is using named areas. First, on the container, you define a template using grid template areas. You visually map out your grid using names you invent, like grid template areas, header, 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 sidebar, main, main, footer, footer, footer.
Whoa, you draw the layout with names.
Exactly. Then on each grid item, you just assign it to a name using the grid area property. So
Yeah.
header, grid area, header, aside, grid area, sidebar, etc. The browser then places the items according to your named template. It's incredibly intuitive.
That's amazing. Much clearer than line numbers for big layouts. What about alignment within grid? Similar to Flexbox.
Very similar concepts, yes. You have properties to align items within their individual grid cells, justify self, align self. Properties to set default alignment for all items in the container, justify items, align items. And properties to align the entire grid structure itself within the container if it doesn't fill all the space, justify content, align content. Lots of control.
Let's do another practical example. That responsive image gallery we talked about, how would grid handle that beautifully?
Perfect grid use case. You'd have your container, maybe div class gallery, holding all your image tags.
Okay.
Then the CSS would be remarkably simple. CSS.gallery, display.grid, grid template columns, repeat, autofit, min-max 200px 1FR, gap 1 rem, add space between grid items, gap. Ensure images fill their grid cell nicely with 100% height.auto display lock display.
That's it. Just display.grid and that repeat autofit min-max line.
Pretty much. The gap property adds spacing between the images. The MG styles just ensure the images behave well within their assigned grid areas. That grid template columns line does all the heavy lifting for responsiveness. It automatically creates the right number of columns, each at least 200px wide, expanding to fill the space. No media queries needed for the column layout itself.
That's incredibly concise and powerful, so you don't actually have to choose between Flexbox and grid, right? They can work together.
Absolutely. That's often the most effective approach for real-world layouts. They complement each other perfectly. Don't think of it as Flexbox versus grid. Think Flexbox and grid.
How do they work together best? What's the strategy?
The common best practice is grid for macro layout, Flexbox for micro layout.
Macro versus micro.
Use grid to define the overall page structure. The big blocks like header, sidebar, main content area, footer. Grid excels at arranging these main regions in 2 dimensions.
Okay, the big picture layout.
Then, inside those grid areas, use Flexbox to arrange the smaller components. Like inside your header, which might be a grid area, use Flexbox to lay out the logo, navigation links, and search bar horizontally and align them nicely.
So grid for the page sections, Flexbox for the stuff inside the sections.
Exactly. Or inside your main content grid area, you might have a list of articles. Each article div could use Flexbox to arrange its thumbnail, title, and excerpt.
So you can nest them, put a display.flex on a grid item.
Totally. Or you can put display grid on a flex item if you need a subgrid inside something arranged with Flexbox. They work perfectly well nested inside each other.
That makes sense. Use the right tool for the job at each level.
Precisely. Grid handles the overall page scaffolding. Flexbox handles the arrangement of items within those scaffolded areas. It gives you the best of both worlds.
So let's recap quickly. We have specific styles winning based on specificity. We have the box model defining content, padding, border, margin, and box sizing controlling how width height work. We have units like PX, REM, and VW for sizing. We have advanced selectors for precise targeting. And now Flexbox and Grid for powerful 1D and 2D layout. That's a lot of control.
It really is. Modern CSS gives you incredible power.
Even with all this power, things don't always look right everywhere. What happens when someone views your perfect layout on a tiny phone or a massive TV screen? And crucially, what do you do when things inevitably do go wrong, even on your own screen?
The final crucial pieces. Responsive design and debugging, making sure your work looks great everywhere and knowing how to fix it when it doesn't. This is where the rubber meets the road.
Responsive design isn't just optional anymore, is it? It's essential. People use so many different devices.
Absolutely non-negotiable for a good user experience. And thankfully, CSS gives us the tools to handle it effectively.
What's the absolute first step for making a site responsive, especially for mobile?
Before you even write a line of responsive CSS, you need the viewport meta tag in the head of your HTML. It looks like this. Meta name, viewport content, width, device width, initial scale 1.0.
That little line. Why is it so important?
Without it, mobile browsers often pretend to be desktop browsers. They render the page at a typical desktop width, like 900 TPX wide, and then just zoom out to fit it on the small screen. Your text becomes microscopic. Users have to pinch and zoom. It's terrible.
I've seen sites like that. Awful experience.
This meta tag tells the browser, set the width of the viewport to the actual width of the device and set the initial zoom level to 100%. It establishes the correct foundation for your responsive styles to work properly. Don't forget it.
Rule number 1, add the viewport meta tag. Got it. What's next? How do we apply different styles for different sizes?
That's where media queries come in. These are media rules in your CSS that allow you to apply blocks of styles conditionally based on characteristics of the device or browser window.
Like screen width.
The green width is the most common one, using min width or max width. The mobile first approach is generally recommended.
Mobile first, meaning you style for small screens by default.
Exactly. You write your base CSS to make the site look good on a small mobile screen. Then you use min width media queries to add styles or override base styles for larger screens. Like at Media, min width 768px, styles for tablets and up, min width and 24px, styles for desktops.
Why is mobile first preferred?
It ensures a good baseline experience on constrained devices and often leads to simpler, more performant CSS, as you're only adding complexity as screen real estate increases. The opposite is desktop first, using max width to adjust styles down for smaller screens, which can sometimes be less efficient.
Okay, mobile first with min width. What else can media queries check besides width?
Lots of things. Orientation, portrait or orientation.landscape. But the really interesting ones are the advanced media features. Resolution, like min resolution. 2D PPX for high-density retina displays. Lets you serve sharper images or tweak styles. Pointer. Coarse for touch, fine for mouse. You can adjust button sizes or interactions based on the input type.
Hover or none. Lets you apply hover styles only if the device actually supports hover, avoiding issues on touch devices. Prefers color scheme, light or dark. Detects user preference for dark mode. Prefers reduced motion. Checks if the user wants fewer animations, crucial for accessibility.
Wow. Prefers color scheme and prefers reduced motion sound amazing for accessibility and user preference. They really are. They allow you to tailor the experience much more finely. And you can combine these features too, like at Media, min width 24px, and a hover.hover, to target styles only for larger screens that also support hover.
Very granular control. What about images? Serving huge images to phones is bad. Small images look blurry on big screens.
Exactly. That's solved with responsive images, primarily using the circset and sizes attributes on your indie tags.
Circset and sizes, how do they work?
Circset gives the browser a list of different image files you've prepared, along with hints about their size. Usually you provide the image width using the W descriptor, like .circset image-small.jpg 400W, image-medium.jpg 800W, image-large.jpg 1200W.
So you give it options. How does it choose?
It uses the device's screen density, the current network conditions sometimes, and crucially the information you provide in the sizes attribute.
Sizes. What does that do?
Sizes tells the browser how wide the image slot will actually be rendered at different viewport widths. This is critical. You might write something like sizes max width, 600px, 100 VW, 50 VW,
Yeah.
meaning if the viewport is 600px wide or less, this image will take up the full viewport width, 100 VW. Otherwise, on screens wider than 600px, it will take up half the viewport width, 50 VW.
So sizes describes the image's layout space, and StoreSet provides the image options for that space.
Exactly. Based on a calculated size from sizes and the device's pixel density, the browser can then pick the most appropriate image from the StoreSet list to download one that's large enough to look sharp but not wastefully huge. It's essential for performance and visual quality.
Okay, responsive design. Viewport tag, global first media queries, advanced features, and responsive images with StoreSet and sizes. That's the toolkit. But what happens when, despite all this, something still looks wrong?
Yes. The inevitable moment. No matter how careful you are, bugs happen. Layouts break. Styles conflict. This is where debugging CSS using your browser's developer tools becomes your absolute best friend. Your superpower, really.
DevTools, F12. Right-click, inspect.
Exactly. Every modern browser has them built in, and they are indispensable. Seriously, learning to use these effectively will save you hours of frustration.
What's the main part to focus on for CSS debugging?
The Elements panel, sometimes called Inspector. This shows you the live HTML DOM structure of your page. You can click on any element there.
And see the styles applied to it?
Precisely. In the accompanying Styles pane, or Rules pane, you see every single CSS rule that applies to the currently selected element. Your styles, browser default styles, everything.
And this is where you see the specificity battles play out.
Absolutely. The Styles pane clearly shows which rules are actively being applied and, crucially, which rules are being overridden. They usually appear with a strike-through line.
So if my color blue, rule is crossed out.
You look right below it, or sometimes above it, depending on specificity, to see which rule is winning. It will show you the selector and the property, color.red perhaps, that's taking precedence. It often even shows the specificity score or links directly to the CSS file and line number. It instantly tells you why your style isn't applying.
That alone sounds incredibly helpful. No more guessing.
It's huge. And right next to the Styles pane, there's usually a Computed tab. This is your ultimate source of truth.
Computed? What does that show?
It shows the final calculated value for every single CSS property on the selected element after all the cascading, inheritance, and specificity have been resolved. If you're wondering what the actual font size or margin left ended up being in pixels, the Computed tab tells you definitively.
So style shows the rules fighting. Computed shows the final winner's value.
Exactly. And the best part, you can live edit. Right there in the Styles pane, you can click on properties or values, change them, uncheck rules, add new rules, and see the changes reflected on the page instantly without reloading.
Test fixes on the fly.
It makes debugging so much faster.
Yeah.
You can experiment until you find the fix, then go back and update your actual CSS code. You can also search and filter styles, which is great in complex projects.
What about testing the responsive stuff? Do I have to keep resizing my browser window?
You can, but the dev tools make it much easier. There's usually a device toolbar or responsive design mode. This lets you simulate different screen sizes, presets for iPhones, iPads, Android devices, or custom dimensions all within your desktop browser.
Oh, that's handy.
You can even simulate different network speeds, toggle touch events, and importantly, emulate those media features like prefers color scheme or prefers reduced motion to test how your site adapts to user preferences without changing your system settings. You can also emulate print styles to see how your page will look when printed.
These tools really do turn that "why isn't this working" into an "oh, that's why" moment. It feels empowering.
It really is. Mastering the dev tools is just as important as mastering CSS itself for building professional websites.
Wow. Okay. We have covered a ton of ground today. A real deep dive into the heart of CSS. We started with that invisible rule book, specificity, understanding why styles win or lose.
Then we built outwards with the box model content, padding, border, margin, and that crucial box sizing property.
We learned how to size things flexibly with relative units like rem and viewport units, moving beyond just pixels.
And how to target elements with surgical precision using advanced selectors attributes, pseudo-classes, pseudo-elements, combinators, and there.
Then we tackled the layout titans. Flexbox for one-dimensional flow, and CSS Grid for powerful two-dimensional arrangements, and how they work best together.
And finally, we brought it all together with responsive design principles, making sure it works everywhere, and the essential skill of debugging with browser dev tools when things go wrong.
So after all that, what's the big takeaway? What does this mean for someone listening, trying to get better at CSS?
It means you hopefully now have the foundational knowledge, the mental models, to move beyond just copying and pasting CSS snippets. You can start to really understand why things work the way they do.
You're not just writing CSS, you're speaking the browser's language.
Exactly. You understand the rules and engagement, the cascade, specificity, the box model. You have the tools, flexible units, powerful selectors, modern layout techniques. This allows you to approach styling challenges strategically, build more robust and maintainable interfaces, and create truly fluid, adaptive, accessible experiences that work for everyone, everywhere. It's about moving from frustration to confidence.
That's a great goal. So to leave our listeners with something to think about, given how much control modern CSS gives us over layout and responsiveness, what's a common visual element or design pattern you still see out there on the web that just feels clunky, like it hasn't fully adapted to this modern responsive world?
Ooh, good question. Maybe complex data tables or certain types of multi-level navigation.
Yeah, this can definitely be tricky. So the challenge for you, the listener, is think about that clunky element. Armed with everything we talked about today, grid, flexbox, min-max, maybe even attribute selectors, how might you finally tackle that problem? What visual challenge, big or small, will you solve next with your new CSS superpowers?